Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hi everyone, welcome to today's session of Dynamic Programming Series. Very pleased to see you all here. So before we begin, can I please get a quick confirmation if my voice is clearly audible and also if my screen is clearly visible? I will share my screen. So we are here for Dynamic Programming Series. And also let's just wait for a couple more minutes so that rest of our friends also join. And then we shall be getting started. All right. So, hi Abhijit. Hi Rishit. Hello Naikaj. Thank you everyone for the confirmation. So, how you all are doing? Like, how many questions all of you have done, and what is the number of session that you are attending today? Like, how many of you have continuously attending these sessions? So basically, we are heading towards the end of this session. Like after today's session, what we basically are planning to do is, all right, Abhijit, this is your third session. Okay. So what we are planning to do is today we are going to have a practice session. Okay. Wherein what we will be doing is we will be solving two questions and one question will be given as your assignment. Okay. So that is about today's session. In the next week's session, we are going to do MCM and problems based on MCM. Okay. Cool. And then after that week's session, what we are going to do is we will be having again a practice session where we will be doing questions based on DP. Okay. So for 2 days, in 2 days, we will be covering this, and in 2 days, we will be covering this, right? So that is what the plan for this series is. Okay. So in total, we had 15 sessions. All right. And we tried to cover all the concepts, all the questions basically. Yes, Naikaj, you did almost join all the session, and that was really very nice to see that. So, all right, let's get started. Just give me a moment. Okay. So, let us just start with the first question of today's. That is, as it is being shown, it is the longest arithmetic progression. All right. So let me just read out the question statement for you all. Just a second. Okay. So is this problem statement visible to you all? The problem page that I have shared? All right, thank you, Rishit, for the confirmation. So the question statement reads as, given an array called A of sorted integers having no duplicates, find the length of the longest arithmetic progression LLAP in it. Okay, so the integers that are given to us are in sorted manner, right? So keep that in mind. And we need to find out the length of the longest arithmetic progression in it. Okay, so let us try to understand the example. All right, let me do one thing. Okay, so the example that is given to us is 1, 7, 10, 13, 14, 19, right? So let me add it. Okay, the question that we are doing is length of longest arithmetic progression, right? And the array that is given to us is sorted, right? So the first example that is given to us is n is equal to 6, and the elements that are given to us is 1, 7, 10, 13, 14, and 19, right? Okay, so now in this, the longest AP that we are getting is 1, 7, 13, 19. Okay, and what is the common difference of all? The common difference is 6, right? As you can see, if we take the elements as 1, 7, 13, and 19, it will give you the longest AP, right? Okay, so one of the most common properties of AP is, if we have three elements, say A, B, C, then what is the relation? If all of these three are in AP, then what is the one relation that these three elements have? Yeah, common difference is same, Abhijit. That's right. They will be having a same common difference. That's why they are known to be in AP. And then we have more correct answers as well, Abhijit and Rishit. Okay, so the thing is that that's the same thing. C minus B is going to be equal to B minus. Okay. So what does it makes it as? It means that twice of B is equal to A plus C. Okay, this is the one relation that we have, right? So what you need to do is, when array is given to you, you need to find out the length of the longest arithmetic progression. Now, a very simple brute force approach for this question can be, you can start from all the elements. Like, let us say you are taking one, and then, you will keep on checking the differences of one with all the elements, right? And if you are, as long as you are getting the same common difference, you can keep on moving ahead, right? And you can do the same thing for all the elements. So that is like kind of a brute force, and it will take a lot of time. So that's not optimal. Other thing, it can be that you can just say that, you can take 10 as a middle element, and then what you can do is you can start traversing in this direction, start traversing in this direction, right? So the same thing, as long as the difference that you are getting is same, you can keep on decreasing this, you can keep on increasing this, right? And then you can keep the track of the longest length that you are getting. Okay, so these are not the most optimal way. So here, let's just discuss about the optimal approach that we can use. 1, 7, 10, 13, 14. So the array is 1, 7, 10, 13, 14, 19. Okay. So basically, the optimal approach that we are going to use here is DP approach. Okay. Why DP? As we can see here, first of all, in the question there is an ask for an optimal, like they are asking for the max length, right? And then again, there are choices that we are making here, that whether to add that element inside our answer or not, right? So based on these two conditions, we can say that DP approach is going to be used. Okay. Now let us see how we can use DP approach here. Right. So for DP approach, the first step that we are going to do here is we will, okay, tell me that what is for DP, like we needed to make a 2D table, right? So in what basis we were deciding the dimensions of the table? Like when we did that knapsack problem, in that case, you know what we were doing, that one side was weight, other side was n, right? And on that basis we need to decide that we need to have a 2D table, right? So here, can you tell me that if we are having exactly, Nikes, that is very correct answer, state of variable change. So all right, here I have given you a hint that we are going to use 2D table, which means that two variables are changing, right? It means that two variables are changing, right? So can anyone tell me here what are those two variables that are getting changed? If we are considering to find out the longest AP, and what are the two variables that are getting changed? Just okay, one of them is the most common variable that is getting changed, common difference and the first element. First element, common difference is the right answer. The common difference is being getting changed, right? So one of the dimensions is going to be the difference. Okay, and the other dimension, like a very common thing, I mean, you know, when you are iterating over the arrays, what is the one thing that keep changing? The size of the array, right? So how we are going to denote that? The other thing is n, that is size of the array, right? So nice try, everyone. Very well done. You were able to develop the intuition, and that's very nice to see. So basically, the two states that are changing here, okay, variables changing, right? So the two variables that are changing here are the difference of the AP that we are going to have between the elements and the size of the array, right? So on the basis of that, we are first going to create a 2D table, all right? And how we are going to initialize it? We will basically initialize it with 0. I mean, all the elements will be filled with value 0. Now, see, this is the difference, right? So what is the size that we need to take for it? Just to be on the safer side, the size that we can take for this is the whatever is the maximum value inside the array. Okay, whatever is the maximum value, that can be the max value of difference that we can have, right? So that you can take. So the 2D table that we are going to create, it will be having difference here, it will be having n here. Okay, so n will range from 0 to n, and the difference is going to range from 0 to whatever is the maximum element inside the array. Clear till this point? And initialized with 0. Okay, all right, so please give me a quick +1 if we are sorted till this part. Yeah, see, if the array is given to you, so what is the max difference that you can have? Like if this is 1 and this is whatever element, and the maximum element that is given to you is 30. So max difference that you are going to have is 29. Like let us say if 1 and 30 are the only pair that is making an AP, right? So in the worst case, the maximum difference that we are going to have is 29. So that's why we are going to take the maximum value of the element. Okay, maximum value of the array, sorry. Like in the worst case, the max difference that you can get is the difference between the last element and the first element. Okay, so clear till this point. So thank you for the confirmation. Now let's just move ahead. Let's just see what we can do next. Let me see the array. That is 1, 7, 10, 13, 14, 19. Okay, so we have here 1, 7, 10, 13, 14, 19. Okay, now just look carefully inside this. I am calculating the respective differences that we have, okay, with all the elements. 1, 7, the difference is 6. This is 3, 3. 7, 13 is 6, and we have 13 and 19 is 6. Okay, and yeah, so we have 3 elements with the difference 6, right? Yeah, and then here we have difference 1, 14. Here we have difference 5. That is none of our concern because the main target that we are using is 1, 7, 13, 19. Okay, so basically, can we do it like this? Like, let us say, first of all, we will find the difference. We need to have 2 pointers, right? Is that clear? Because we are here finding out the differences. AP is basically based on differences, right? Based on differences between 2 elements. Okay, so are we clear on this? What is AP? That is basically, it is based on the difference between 2 elements, right? So if we have element as 2, 8 and 14, okay, so how it is, how we can say that it is in AP, because the differences between these 2 elements is same as the difference between these 2 elements, right? So the major factor on deciding an AP sequence is differences. Okay, all right, thank you, Shishir, for the compliment. All right, so what we are going to do is, first of all, we will find out the what is the difference between current element and one of the element, right? We are going to take here 2 pointers, right? Let us say our first pointer is at 1, okay? And our, no, not 1, because, okay, let me take another example. Let us say our first pointer is at 7, okay? And our second pointer is at 13, right? So we will find out the difference between these 2 elements, right? So what will be the difference between 13 and 7? The difference is going to be come out as 6, right? So the difference between 2 pointers, let us say this is J, this is I, okay? So what we will do is we will fix one of the pointer here, and then we will start iterating from the 0th index. We will iterate till this I minus 1th index, okay? And for every element, we will calculate the difference, right? Now, let us say the difference that we are getting is 6, okay? Now, the difference 6, let us say that you have already once having the difference 6 by taking the difference between 1 and 7, okay? When you have calculated the difference of 1 and 7, at that time difference 6 was already you received, okay? So the count of difference 6 is already 1, right? So what we can do is, when we again encounter the same difference, that is 6, can we do an increment here? Okay, and then after that, again, when you will encounter the same difference, that is 6 here, that is 13 and 19, can we again do an increment here? 3, that the difference of 6 is coming out to be as 3 times, right? So in that way, we can keep a track of how many times a certain difference is occurring. Okay, so whatever is the number of times a certain difference is occurring, at the last we can simply return that number of times plus 1. Okay, and you can keep the track of the maximum value, obviously. So is this concept clear to you all? Like, if it is not clear, please feel very free to ask in the chat section. I will explain it again. What I said is that AP is based on differences between 2 elements, right? We had a 2D table based on difference and n, that is size of the array. What we are going to do is, for every difference, we will keep track of how many times that difference is occurring. Yes, exactly. We are going to find out the difference between all pairs of the array. All right. So, like, by all the pairs, I mean that, yeah, it will be like, you will be iterating. One of the pointers will be kept fixed. Other pointer, you will start from here to here. So basically, yeah, you will be calculating the difference between all the elements. Okay. All right. So let me just repeat it, what I said, that basically what you need to do is, you need to have a record of how many times a certain difference is occurring. Okay, if this is your 2D DP table, right, here we are maintaining the difference, here we are maintaining the n. So what this cell will denote is, this cell means that for this difference, okay, let us say the difference is 6, okay, for this difference till ith index, okay, this is, let us say, I, till ith index, the maximum length of AP that we have, okay, that it is going to show us, right? So that is how, and let me just do a try run for this 1, 7, 10, 13, 14, 19. Okay, it will become more clear. So let us say this is the DP table that we have played. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 4, 5, 6. I need to erase this. All right. And this is the difference. Okay. 0, 1, 2, 3, 4, 5, and 6. All right. 0, 1, 2, 3, 4, 5, 6, and here we have size of the array. Okay. So initially what we have done is we have initialized every cell with the value 0, right? Now this is a difference of 6. Okay, this is the difference track. Okay, and this is the size track, right? So now here what we are let us say everything is initialized with 0. I'm just depicting you the dry run for the difference of 6. Okay, now when my j is here and I is here, okay, what is the difference I'm getting is 6. Okay, so what I will update is t at difference and I is equal to t at difference of j plus 1, right? Simply I need to increment it, right? So initially t at difference at j means the difference is 6 and the value of j is 0. Initially it is 0. So what I can write at I as, it will become 1, right? Here we are having 1. Okay, now once again when you will encounter the difference of 6, that is when the I is here and j is here, right? So how you will update I, you will simply write it as the t of difference of j plus 1, means whatever the longest length that you have achieved till this point, simply add 1 in it. So the longest length that we have achieved is 1, and we will simply add 1 to it. We will be getting 2. So 0, 1, 2, 3. At 3 you are going to write it as 2. Okay, another 6 that we are going to achieve it as at 19. So at 19 what we have is, okay, so this will be the value of I and the value of j will be here. So 0, 1, 2, 3 at third index. So how you are going to update at ith index is whatever is the longest length that you have achieved till jth index plus 1. So the longest length that we have achieved is 3, and sorry, the longest length that we have achieved is 2, and when you will do a plus 1 at ith index you are going to get 3, right? So in this way, and at the end you need to return whatever is the answer coming plus 1. Why plus 1? Because if you are getting the differences n number of times, then the total number of elements are n plus 1, right? So that is how the table will be getting filled. Okay, so is this concept clear to you all, how we are filling out the table? You just simply need to update the table as t of difference I is going to be t of whatever is the previous difference plus 1. Simple, right? Just this is the main concept behind this question. So please let me know if this concept is clear to you all. And give a quick plus 1 in the chat section. Okay, thank you, Rishit, for the confirmation. Let's just wait for few more people to confirm. Sorry, few more people to confirm. All right, Abhijit, you can have any of the x's for difference and any of the x's for n. Okay, that is irrespective of it. Whatever you want to keep in row, you can keep. Whatever you want to keep in columns, you can keep. Okay, there is no any significant difference in that. Yeah. All right, everyone. So I am waiting for a plus 1 from you all so that I can show you the code for this question. So please do give a plus 1 in the chat section if it is clear, or you can ask doubts. Okay. So let us see how many plus 1 we are going to get. Okay, thank you, Abhijit. Thank you, Rishit. Why the number of +1 is not equal to the number of participants that we have currently? Like rest of the people, are they not able to understand the question? Then like you can ask me. Or if you are able to understand, then please drop a +1. Okay, so I assume that this question is clear to you all. So let me show you the code for this question. This is the code. All right. So what we have done here is, first of all, we have initialized our answer with the value 0, obviously. And then what we are doing is, thanks, Empire. And then what we are doing is we are simply iterating. As I said, we will be having 2 pointers, right? One pointer placed at the end and then other pointer starting from 0 till that end pointer, okay? Till the end point of that previous pointer, right? And then you will simply calculate the difference and then you will update your DP table, right? So that is how we are going to find out our answer. And then at the last, simply you can return the answer +1. Because as I said, if the number of differences that you are getting is t, so the number of elements that is there in the AP will be t+1. Okay, so this is the code of the question and I hope that it is visible also. If there is any doubt in the code or in the concept, please feel free to ask, or otherwise drop a +1 in the chat section so that we can move towards our next question. So this is also another example that we have 2, 4, 6, 8, 10. Yeah, the whole set is in AP, obviously. All right, guys. So I hope we are comfortable with this question now. Now let us just move towards another question. Before that, just give me a moment. Share my screen. Okay. Right. So this is the next question that we are going to discuss. So what the question statement reads as, given a binary matrix of size n cross m, find out the maximum size square submatrix with all ones. Okay. So what you need to do is in input and what is given is you have a square matrix, right? And the elements inside that square matrix is either 1 or 0. And then what you need to find out is you need to find out the length of the maximum size of the square submatrix which is having all 1. Okay, right? So this is what the question demands from us. Now let us analyze the input and output. Share screen. Okay, this is the second question that we are going to discuss. Yeah, exactly, Nikaj. As we have discussed in one of our sessions, just give me a second. Okay, so as we have discussed in one of our sessions also, that DP is mostly like, the optimal approach. Whenever there is like kind of max thing is asked to you, you can be like kind of thoda sa sure that, it is going to use DP. Okay, so that is what the DP is about. Okay, this looks like the area of largest island type of question, and that is basically a DFS based kind of a approach, right? That we use there. But here it is like the DFS approach is not going to work majorly. We are going to see that how we can use, we can solve this question with the help of DP, okay? And okay, so for the DP, the prerequisite topic is recursion. Obviously, recursion is the parent of DP, so make sure that your recursion is strong. You can do the direct DP, but only when you have this notion in your mind that how we are arriving from the recursive solution to the DP solution. Okay, once you have that notion, once you are able to see a question in that way, right, that how a question is, like there is this Fibonacci wala question, okay, so that you can solve with the help of recursion, right? But recursion is taking lots of time, okay, because we are having two recursive calls for every function, right? So that is not a very wise choice. So that's why we switched to DP, right? So you should have this notion that why we switched to DP from recursion and how we can derive to the DP solution with the help of recursion. So basically you need to be strong in recursion if you want to start with DP, right? So once you will get comfortable with that, then in some of the cases you can directly arrive at the DP solution as well, right? So longest square submatrix. So the example that was given to us was 1, 1, 1, 1, and the output that is given to us is 2. Obviously, we can see that the longest size that we are getting here is 2 only. Okay. Verify icons, yeah. Now, let me just see if you are able to understand the input and output in a clear manner. I will just draw a matrix here. Let us say if our matrix is 1, 1, 0, 1, 1. Okay, so what is the output that we are going to get for this matrix? What is the largest square submatrix that we have here? 2, right? Okay, so input and output is clear to us. Okay, so what the question is basically demanding is that this binary square matrix is given to you. You need to find out the length of the longest square that you have. Okay, now when you are solving this question, what are the things that we are looking at? If this needs to be a square, right, it means that let us say we are analyzing this element. Okay, now if this needs to be a part of the square submatrix, then what is one of the requirement is that all these three cells should have one inside it. Is it clear? Like if any of these three cells, its three neighboring cells will have 0, then it is for sure that this cell is not going to form a square submatrix. Is this concept clear? What I just said right now? That if we are analyzing a cell I and J. All right. Thank you so much for saying this. I'm happy that I'm able to influence you in a positive way. Okay. So, yes, Samson, that's the right answer. So, okay, let us say we are analyzing an element that is at the value ij. Okay. So, what we need, the one of the basic requirements is this value at I minus 1, j minus 1, I minus 1, j, and I, j minus 1, right? All of these cells must have one inside it. Is this concept clear to you all? Yes. Thank you everyone for the confirmation. Now, the first condition that we need to check is that all of these must have one. Now tell me one thing. If any of this is having 0, we are not going to get a square matrix. Okay. Now we need, once you have checked this condition, this is the first condition. The second thing that you need to do is you need to find out the length of the longest square submatrix that you are having. So to find out the length, what we need to do is, like, if this is the cell that you are analyzing, okay, so if you need to find out the length of the square submatrix, so let us say the length, let me just enlarge this box only. Okay. Sorry, Nikos, I didn't get your question. At bottom, there are 2 0, has 1. Then it should be count as square matrix. I don't see any square matrix here. Like, can you tell me the index value you are talking about? If these are the indexes that we have. Okay. So can you tell me what index value you are talking about here? Till then, let me just enlarge this cell only, okay? If I have enlarged this cell, so what values we have is 1, 1, 1, 1, okay? Now let us say 2, 2, 3, 3. So at 2, 2 we have 1, at 3, 3 we have 1, okay? So, okay, so let us say we have enlarged this cell value, okay? Now we have 1, 1, 1 here, okay? So how we are going to decide that what is going to be the length of the longest square matrix, okay? For that, what you need to do is you need to find out what is the length that you have till this point, right? And whatever length you have till this point, you will simply add 1 to it, and then you will get the maximum length here, right? Let me just okay, so we have here, just a second guys, okay, let me just solve one doubt. 3 2 3 3, at 3 2 we have 1, okay, and at 3 3 we have 0. So how it is going to form a square matrix? It is not like, by square matrix we mean that the n number of rows and the m number of columns, right? If you are using n rows, then you should use m, and if you are using m columns, then value of n should be equal to m. Okay, that is here the meaning of square matrix. Like this part is not going to constitute a square matrix here, right? Let me just again show it to you guys. Like, let us say we are having a square matrix of size 3, okay, and let us say if all of this is 1, okay. So what we are going to do is, first of all, you are going to find out that what is the maximum length that you have here, okay. Whatever the value you have here, you just simply need to add 1 to this point, so this becomes 2. So this means that the maximum square size we have till this index is 2. Okay, now let us say we are analyzing this element, okay. Now we will again check that whether all the elements are 1 or not, okay. So if all the elements are having 1, then what we will do, we will simply update it as whatever is the value here plus 1. Okay, so what we are going to get is 3. So as you can see, the maximum square submatrix size here is 3 only. Okay, so is this concept clear to you? What we do is, first of all, check all the neighboring elements are 1. And if they are 1, then how we are going to update, we will create a 2D DP table, okay. So how we are going to update it as T of ij is going to be, yeah, we are moving diagonal way, okay. So what is happening is T of ij will be minimum of whatever you have in all these neighboring cells, okay. Find out the minimum of that and simply do plus 1, right? Because you know, if like, let us say the minimum value that you are going to get, and it will keep a count, okay. The new array that we are creating, it will basically keep the count of the length. Okay, it will keep on the count, right? So basically what we are going to do is find out if all the neighboring, basically find out if the diagonal element is 1 or not, right? And if it is, then simply update it whatever is the minimum from all those neighboring and simply add 1 to it. Why 1? Because there will be an increase in size by 1 cell. Okay, yes, exactly, we have to check all the 3 cells. Okay, but then if you are checking it for the diagonal, what we will do is that T of ij, we are anyways initializing it with the value 0. Okay, so if it is a 0, so if you are updating it without just checking the diagonal value, so, and like, let us say okay, good question. So let us say this is the T, okay, the new table that we have created, okay. Here we have the maximum length that we have achieved is 2, and here if it is 0 and 0, and if in the matrix, if let us say this cell is having 1 inside it, right? So what it will happen here is, here the length will be not updated as 3, here the length will be updated as 1 only. Why? Because these two elements are 0, right? So in your T array, what it is going to have, it is going to be 0 only, right? And how we are updating is we are updating it as minimum of neighboring cells, whatever the value you have at neighboring cells, and simply do +1, right? So it will be, it is getting taken care of. Whatever the minimum value that you have in your neighbors, simply add 1 in it. Okay, so that is how we are going to approach this question. Just create, we write down the steps. Create a 2D DP table. Okay, why 2D? Because the two state of the variables that are changing here, that is very common. The number of rows and the number of columns are changing, right? So we are going to create a 2D DP table. Second step, initialize it with 0. All right. And in the third step that we are going to do is, for this question, DP is better because you can't use DFS here because it will be not giving you, the count of the largest length that you are having till this point. Okay, you could have used DFS when the question would have been that count the total number of ones that are connected in a cell, right? In that way, you can use the DFS, but here it will be better if you use DP. Okay, so after initializing it with 0, check for the previous diagonal element and it has to be 1. Okay, two cases. If it is 1, then increment current cell value by 1, or if it is not 1, then you don't need to do anything, it will be 0 only. Okay, the cell value will remain 0 because that cell is not adding any value to your square. Okay, so these are the steps that we are going to follow. Okay, now let me show you the code. Yeah, here it is. Yeah, so this is the code of the question. Do let me know if you have any doubts in this. Okay, so what about the steps of taking the minimum? Okay, so what we are going to do here is, I will just explain it to you. Just a second. Just give me a moment, guys, okay? Is it clear now? Is my voice audible now? Okay, so what we are going to do is, as I mentioned here, we will find out the minimum of neighboring cells +1. Now, let me explain you the concept behind this. The concept is basically, let us say this is our T. Okay, so let us say the maximum length of the square that you got till this point, here it is 2, here it is 1, and here it is 3. Okay, the maximum size that you are getting. Now, if here also it is a 1, right? So what we are going to do is, you can't update this current value on the basis of the maximum value. Okay, you need to update it on the basis of the minimum value. Why? Because let us say if we have This is 0, right? This is 1, 1, 1. Okay. So if you are updating the size of the square for this, okay, you can't update it because like let us say here we have the count of 1 as 1, here we have count of 1 as 1, and here we have the count of 1 as 0. Okay, so if you are trying to update it, am I audible now? Okay, so please can I please get a confirmation if I'm audible now? Okay, thank you. So what we are going to do is, let us say the number of count for this cell is 1. The number of count of 1 for this cell is 1. The number of count of 1 for this cell is also 1. Okay. And the number of count of 1 for this cell is 0. All these three are the neighboring cells. Okay. So if you will update the value of this cell on the basis of count of, like, let us say if you will say that, okay, the count of 1 is 1 here, I'm going to update it as 2. But that is wrong because it is not forming a square of size 2, right? So that's why what you need to do is you need to find out the minimum of all the cells, right? And then you need to do a +1 in that. Okay, so that's why the step that I have written here is in the line number 22. Okay, that is meant for that thing. Clear? Okay, who asked that doubt? Okay, Rishit, is it clear to you now why we are doing this minimum thing? Okay, that's very nice to know. And I will now again share my code. All right, guys, so this is what we have. If there is any confusion in the code, if there is any confusion in the concept, please feel free to ask. And the one question that you are going to get for the assignment is, actually the description is provided in, the link is provided in the description as well. One question that is painting the fence. Okay, so that is your assignment. All of you need to solve that question, and then we can discuss it in our next practice session. Okay, I will add it again in the comments. Yeah, so that is all about the two questions that were planned for today's session. Okay, and I hope I was able to clarify the concepts. I hope I was able to make you all understand the question that we are solving. All right, guys. If there is any confusion, please feel free to drop it in the chat section, or else we are good to wrap the session. Yeah. All right, guys. So thanks for joining. Thanks for attending the session. And I hope to see you all in the next session as well. Till then, everyone, take care, stay safe, and keep up the hard work. Good night, everyone.